Hey, good morning, children. How are you all? Today, we are going to start up a new chapter called Programming Concepts. So, let's get started. Okay, by reading this particular chapter, that is Programming Concepts, what are we going to learn? We are going to learn about the problem solving techniques, algorithms and flowcharts, standard flowcharts, and symbols. Okay. See, before we learn up the programming concept today, the topic which we are going to discuss, what is the base behind that is see, we know that the computer is a most fastest processing machine, correct? It processes your problems, your um, softwares or anything with an accuracy of 100%. Yes, yes, children. See, computer does our work completely without any error, without any mistakes, and with the highest speed with an 100% accuracy, right? When I say accuracy means no errors, no mistakes at all. But see, it depends upon what data you are giving, right? So if you want the computer to do 10 plus 10 and you want the answer to be 20, if you give the computer that do 10 plus 5, by mistake you have given 5 instead of giving it 10, will it give you a proper result? No, right? So it depends upon the data which we are giving. Okay, we are telling the computer to go do some like for example, I'm telling the computer to go to market and bring some vegetables for me. Okay, so instead of asking the computer to go for market, I said the computer to go for school and get the vegetables. Will it get the vegetables for me? No, right? Because the instructions which I'm giving to the computer. See, now don't ask me the question saying that, ma'am, how can a computer go to a market? When I am keeping a computer in my mind, I can think about the robots also. Robots are also computers, right? They are machine. They are robotic machines. So whenever I tell the computer to do something for me, I have to give a proper instructions, correct? So whatever you say, the computer will do exactly and only that much. Neither it will ignore any of your instructions, neither it will overdo something. Okay, you ask the computer to get the vegetable, it will go to the bakery and buy the breads also. No, you have told vegetable, it will only follow till vegetables and come back home. Yes, if you say computer to do 10 plus 10, it will give only do 10 plus 10. It will not do 10 into 10 and 10 divided by 10 or extra. No. So the result of the computer which we are going to get it, if you want a proper 100% accurate result, then our data which we are giving to the computer also should be accurate. It depends upon our accuracy, right? This means it is user's responsibility. Who is the user here? It is we, the user of the computer, because we are the user, we are using the computers, right? So we become the user over here. So this means it is user's responsibility to provide proper instructions to the computer so that it can perform the given task correctly, right? If you're giving a task to the computer to do something accurately, like correctly, then you're supposed to give the instructions also properly, because at the end of the day, it is a machine, right? It's not a human being. If at all, maybe sometimes what happens when we are speaking up, when we are giving in instructions, we think that the other human being will understand what are we trying to talk. Half information is also okay, they think about it, but can a computer think? No, right? So we are supposed to give proper instructions to the computer so that it can give correct results also to that. Yes, to get a particular work done, instructions are to be given to the computer in a proper sequence also, right? In proper stepwise. When I say sequence, I am telling what to be done fast and what is to be done next and what is to be next day. Like step one, step two, step three should be step three only. You cannot mix up. Okay, you cannot directly say Like for example, again the same thing, I'll take going to the market and buying some vegetables. Okay, you said to the computer, go to the market, buy some vegetables, then go to the bakery, buy if money is left out. Okay, if money is left out after buying the vegetables, then you go to bakery and buy some bread for you. Done. But instead of that, what did you say? Go to the bakery, buy bakery items, and then go to vegetable. If money is left out, then you buy the bakery item. Do you think computer will understand? It will get confused. What did you say? The computer, instead of telling him to go and telling it to go to the market first, and if money is left out, then go to the bakery. But what did you say here? You actually said to go to the bakery first. So what will computer do? It will directly go to the bakery. It will buy whatever bread you have asked it to buy, and then go to vegetable and then buy whatever left out money will be there. In that, it will buy the vegetable and come back, and it will say there was no money left. Correct? So this is the way. So whatever you want to do, get it done. So proper step by step instruction should be given. What should be the instruction at the first step? What should be the instruction next? Okay, instead of that, let's take a simple example. You are coming from Chittapur to school. Okay, your robot or your computer is coming from Chittapur to school. So how it is supposed to go? So first it has to come out of his house, then reach the underbridge. From underbridge it has to take a left, then come straight. There are more left and rights, right? So you're not supposed to go take any left and right. Keep coming straight. And at the Orient crossing, take a left, right? Again come till across 3 roadway, again take a left, take a board, right? Like this you're supposed to give the instruction. Instead of that, if you say come out of your house, reach to the under bridge, from there take Chittapur road, sorry, take Diggaon road, and then take wherever you want to left, right? Instead of telling right, you take first right or first left. Correct? So what happens here, the computer will get confused and it will not reach its destination properly. So that's why whatever instructions you're giving, it has to be in a proper step. What needs to be done first, what needs to be done next. Before you pass these instructions to the computer, it is very important to decide sequence of the test step in solving a particular problem. Exactly what I say. So when you are when you are giving an instructions to the computer, it is very important to you to decide which step should come at what number. So the sequence of the step should be properly given in solving a problem. Imagine you are solving a maths problem. Okay, children, you are solving a maths problem wherein you are supposed to do addition also, multiplication also, subtraction also. First you are supposed to calculate a number, one what do you say, problem, and then related that answer will be used in another problem, right? Like that. So in that, how you are supposed to go step by step, that way you're supposed to give the instructions to the computer also. So whenever you're trying to solve a computer problem, or whenever you want to give some instructions to the computer to do some problem, then you're supposed to give the instructions properly, accurately. All the data should be proper, and importantly, the sequence of the steps which are supposed to be followed. Obviously, right, children? Let's take an example. Here is a very interesting example for you all. Planning a program. So now we are planning a program to make a tea, a cup of tea. To design the solution of the problem, divide the problem into the small steps and put them into the correct order. Right? Now we want our computer. We are giving an instructions to the computer to make a cup of tea. So firstly, we should never write the steps in paragraphs. Okay, no big. Computer will not understand it big. So every problem solution should be divided into small steps. Okay, whatever instructions you're giving. It is just like how your PT teacher gives you an instructions about turn, take left, take right, 10 step forward, 10 step back, right? While even when you're marching also, like right turn, left turn, right? All those things. So likewise, the same way you're supposed to apply it over here also. So let me take you through how to make a cup of tea first. Okay, so the first step to make a tea is take a vessel, right? Take an empty pan, pour water in it, put it on the gas burner, right? First take an empty pot, put it on the, pour some water and put it on the gas stove and switch it on. See, when I'm saying switch it on, if I say the computer to fill the, put water in the vessel and put it on the gas stove. So if it does not on the gas stove only, then how is it going to boil? So the instruction, see, I'm again and I'm again telling you, computer will only do what you are going to instruct it. So first, what are we doing here? So the first step, we are supposed to take an empty vessel, pour water in it, put it on the gas, switch it on the gas and let it boil. So once you have boiled once the water gets on the boil, please put some tea powder, sugar, milk and let the water come to the boil and pour it on the in our cup and then put some milk. Yes. So what we have done over here? Take an empty pan, pour water in it, put it on the gas burner, put tea leaves into the boiling water, add sugar, pour milk to the boiling mixture, boil the mixture, strain into the cup. Tea is ready to drink. So algorithm is, so this is whatever we have written in front of us, right? This one. Take an empty pan and all. These steps of 9 steps. So whenever we are planning a program, okay, or whenever we are trying to solve a problem, whenever we want to um, find a solution of the problem, so first we write down the steps to solve it, right? First we'll do this one, second this one, then this one, then any problem. So be it like a birthday party also, whenever we are planning a birthday party also, it's a program, right? So we first step sit down and plan it up, right? This one will be the decoration, then for this what all we need it, and then what will be the food for that, what all things are we going to be requiring. So we sit down and we write it down, right, in small steps, what needs to be taken care, which thing should be taken care at the first point, right? So such step by step, sequentially. Okay, so when I'm saying step by step in a sequence manner of putting a solution to the problem, this step by step instructions, whatever we are writing, is called as algorithm. So it is called as algorithm. So algorithm is nothing but, algorithm is a process of solving a problem step by step in a sequential manner. I repeat, so algorithm, what is an algorithm? It is a process. Okay, it is a, if you're getting confused with it, it's a method. Okay, it is a method of writing down. It is a method of writing down the solution of a problem. The solution of a problem. How are we writing the solution of a problem? Step by step. And the step should be in a proper sequence manner. So this is called as algorithm. So when we are writing an algorithm, we need to keep some points in our mind. So let me take you through those points. So while writing the algorithms, we are supposed to follow these particular points. The first one, always begin the algorithm with the step called start and stop, right? See, like your PT teacher, whenever you are having a race or whenever whenever you are giving a instructions to the computer is not a human being, right? Or like get set go, right? Likewise, so computers, it needs to understand. So first you're supposed to say start. to the computer. So when you say start, when you write, the first step should be start. So when the computer reads the word called start, it understands that the next instructions are a problem solving instructions or a program instructions. Okay, so you have to have a proper start. And if you do not put stop at the end, computer will not understand where it has to stop, right? Where it has to come and stop. So see, I gave you an example of going to the market. So if you say start computer, so computer will get out of your class, go to the market, buy the vegetable, come back. It does not know where it is supposed to stop. So it might continuously do the same thing, like start, get up, go out, buy the stuffs, come back home. Again, go out of the house, go for the market, pick the things and come back home. Again, the same thing. So until and unless we instruct the computer to stop somewhere, it will not get stopped. So that's the reason. So your algorithm, so the steps which you're going to write it, it has to, the step one should be always a start. And the last step, after you finish writing everything, wherever you want to stop, your last step should be stop. Give a line number to each instruction. So whatever instructions you're giving to the computer one by one, it's, as I said earlier, it should not be like a paragraph. It should be a small instructions, right? So each instruction should be given one number. For example, on a safer side, we always follow the rule of step 1, step 2, step 3, step 4, right? You can see it on the screen, step 1, step 2, step 3, step 4, step 5. Yes, give one instruction numbers to the instruction. So computer will also understand. So imagine you have written step 1 here and step 3 here, and by mistake your step 2 has come here. Computer will at least know that this is the step 2 and then this, the next one is step 3. So it will follow your numbered instructions. Do first this one, then do this one secondly, and do this one thirdly, right? Functions of each statement should be given very clearly. This was the first point when we started this video today. The first point is whatever instructions you're giving should be clearly communicated. Let's take an example of adding two numbers, sum of two numbers. So how are we going to do? So we are telling computer start. Read the two numbers n1 and n2. So see here, why am I taking n1 and n2 is, just for example, I can add any numbers. If I just say 1 and 2 or 3 and 4, so what happens? Computer will take only that number. When I'm giving n and n1, I am just providing a space. There I can write any number, keep changing the number and the result will be done. So n1 is my first number and n2. So you're supposed to add, computer is supposed to add these two numbers and it should display the result. So read the two numbers n1 and n2 and result is equal to n1 plus n2. Fine. Now I have to tell the computer to display the result. If I do not use the step display result, what will computer do? It will add and keep it in his memory only, right? See, example, I'll tell in an exam, there's a competition going on and I'm giving a number to the child, do addition of 5 plus 5. So in the mind, okay, it did in the mind, okay. Until and unless you tell the student to tell the result, will he or she be telling it? No, right? So you have to tell, add this plus this and then answer it, right? So that way display the result and finally stop, right? This is how we figure. See here, what did we do? We were making a T, right? Let me see here also we have put everything step by step, step 1, step 2, step 3, step 4, step 5, 6, 7, 8 and 9. So we did simple program of making a T. So this is this one, and here we did a program of adding two numbers. So you can see how we have written the addition in stepwise, right? So this is how you write an algorithm. So step-by-step instructions in a proper sequence is called algorithm. And every time when you're writing an algorithm, you're supposed to make sure it has a start point, it has a stop point, Give a line number to each instructions. Write each instruction in separate line. Function of statement should be very, very clear. And we'll go quickly towards your flow charts. We studied algorithm, right? Now we will be seeing something called flow charts. Now, what are flow charts? So what do you mean by flow? Flow means following something, right? Chart is displaying something on the chart, right? So the same thing is applied here. The instructions which we have written in the algorithm format, right? That now the same instructions we are going to write in a chart format. And each step will be coming down. So the flow of the information is going from top to bottom. The flow of instruction is going from top to bottom. And how do we put it on a chart, right? We make some boxes. In the boxes, we put some information, right? Flowcharts are the diagrammatic representation of algorithm steps used to solve a problem. So whatever we are writing in the algorithm, right? What is algorithm? Step by step writing of a problem, solutions of those problems. Okay. So now what are we going to do in flowchart is we are going to take these algorithms and put it in flowchart. How? In a diagrammatical way. So we are going to draw something. Okay. Just have an imagination. We are going to draw some shapes. In that shapes, we are going to write the steps. And the first step will be at the top and the last step will be at the bottom. So what is the first step? Start. What is the last step? Stop. So between the start and stop, we are going to write different instructions, but again, those instructions are going to be step by step in a sequential manner only. To create a flow chart, some standard symbols are used, okay, where each symbol represents a specific type of operation. Whenever we are drawing a flow chart, okay, I'll just show you the full flow chart. Now, can you see here? Can you see some diagrams over here at my left side? Yes. Can you see these are different shapes? There's some oval shape. We have a diamond shape. We have some rectangles, squares, right? So these are the diagram. This is called as a flow chart. Can you see, is everything going upward? No, almost everything is coming downward and each and every box is connected to each other, right? This is how your flow chart actually looks like. So this is your start point and this is your stop point. And your information will flow from top to bottom, right? So to create a flowchart, some standard symbols are used where each symbol, so what kind of a diagram we are supposed to use? So that is already been decided. That is already been fixed up by the systems, saying that which box belongs to which instruction, right? Start and stop symbol should be written, start and stop should be written in which type of box or which type of shaped box, right? And looking at the box only, we can make it out, right? This particular box belongs to which instruction. So these symbols are connected with each other by solid lines with arrow marks called as flow lines. Can you see these arrow marks? Yes, this is called the flow line. So with looking at this particular flow lines only, we can make it out how the instructions are going. Let us take this right side one. So it is going to start here and coming to the diamond shaped box. Then from here, it is going towards a rectangular shape, twisted rectangular. From there, it is coming down and then it is coming to the center box over here at the bottom. So we can, looking at the flow lines only, we can make it out how the information are going to go from which box to which box it is going. So these are called as the flow lines, right? So each box are connected to with the flow lines. We cannot leave any box without a line over there. So different symbols are used for different boxes. Now we will be seeing these boxes and different symbols in our next class. So until then, please read your textbooks and try to understand the concept again. And if you face any problem, just contact me back. I'll be explaining again with few more examples. So until then, bye bye.